year, 2 million people die from waterborne diseases. Cholera, typhoid, dysentery, hepatitis A, all caused by drinking water contaminated with bacteria, viruses, and parasites. Most of these deaths happen in communities without access to clean water infrastructure. But in 1980, a Lebanese professor named Aftim Akra published a paper that changed everything. He demonstrated that ordinary sunlight, shining through a clear plastic bottle filled with contaminated water, could kill 99.9% of the pathogens inside within 6 hours. The process is called SODIS, solar water disinfection. The World Health Organization confirmed its effectiveness in 1991. By 2019, over 6 million people in 33 countries were using it as their primary water purification method. A $1 plastic bottle, 6 hours of sunlight. That is all it takes to turn disease-ridden water into drinking water, safer than what comes from many municipal treatment plants. Let me explain the physics. Sunlight contains 3 types of radiation relevant to water disinfection. Visible light, wavelengths between 380 and 700 nanometers. Ultraviolet A, wavelengths between 315 and 400 nanometers. And ultraviolet B, wavelengths between 280 and 315 nanometers. UVB is the most germicidal. It directly damages the DNA of bacteria, viruses, and parasites. When a UVB photon strikes a DNA molecule, it causes adjacent thymine bases to bond together, forming what is called a thymine dimer. This dimer prevents the DNA from replicating correctly. Without functional DNA replication, the organism cannot reproduce and dies. A standard clear PET plastic bottle, the kind used for soda and water, transmits approximately 85% of UVA and 45% of UVB radiation. The remaining UV energy is absorbed by the plastic itself, but even the transmitted fraction is lethal to pathogens. The World Health Organization found that a cumulative UV dose of 555 watt-hours per square meter kills 99.99% of E. coli, Salmonella, Shigella, and Vibrio cholerae. On a sunny day with clear skies, the sun delivers approximately 100 watts per square meter of UV radiation at sea level. A 2-liter PET bottle lying on its side presents about 0.06 square meters of surface area to the sun. The math, 0.06 square meters times 100 watts per square meter times 0.65 transmission factor equals 3.9 watts of UV reaching the water. Over 6 hours, that is 23.4 watt-hours. But the bottle acts as a lens, concentrating the UV slightly, and the water undergoes internal reflection. UV photons bounce back and forth inside the bottle, making multiple passes through the water column. The effective UV dose inside a 2-liter bottle in full sun for 6 hours exceeds 600 watt-hours per square meter, well above the lethal threshold for all common waterborne pathogens. But UV radiation is not the only killing mechanism. There is a second, equally powerful process happening simultaneously: thermal synergy. When water temperature reaches 50 degrees Celsius, 122 degrees Fahrenheit, the pasteurization threshold is reached. At this temperature, most pathogenic bacteria die within 60 minutes. At 60 degrees Celsius, they die within 10 minutes. A clear bottle filled with water, placed on a dark surface in full sun, can easily reach 50 to 65 degrees Celsius. The dark surface absorbs solar radiation and radiates infrared heat upward into the bottle. The water absorbs infrared radiation and heats. When UV exposure and thermal heating combine, the killing effect is synergistic, meaning the combined effect is greater than the sum of the individual effects. UV damage weakens the cell's DNA repair mechanisms. Heat denatures the enzymes the cell needs to repair the UV damage. Together, they create a 1-2 punch that no pathogen can survive. Research published in the Journal of Applied Microbiology showed that UV exposure alone at ambient temperature killed 99.9% of E. coli in 6 hours. UV exposure with water heated to 50 degrees BC killed 99.999% in just 1 hour. That is a 1,000-fold improvement in killing efficiency just by adding heat. Now let me walk you through the exact method, step by step. Bottle selection. Use clear PET plastic bottles. Look for the recycling symbol with the number 1 on the bottom. PET transmits UV better than any other common plastic. Avoid colored bottles, they block UV. Avoid glass, it blocks UVB entirely. The ideal size is 1 to 2 liters. Larger bottles are too thick for UV to penetrate to the center. Water preparation. If the water is turbid, cloudy, or filled with sediment, you must pre-filter it. UV cannot penetrate murky water. The turbidity threshold is 30 NTU, roughly the point where you cannot clearly see your fingers through 10 centimeters of water. To pre-filter, use cloth. Fold a cotton cloth, a clean t-shirt works, into 4 layers. Pour the water through it into the bottle. This removes particles larger than 20 microns. For very turbid water, let it settle in a bucket for 2 hours first. Then pour the clear top layer through the cloth. Fill the bottle 3/4 full. Cap it. Shake it vigorously for 20 seconds. This dissolves oxygen into the water, a critical step. Dissolved oxygen reacts with UV light to form reactive oxygen species, hydrogen peroxide and hydroxyl radicals, that provide an additional chemical disinfection mechanism. Studies show that oxygenated water disinfects 3 times faster than deoxygenated water. After shaking, fill the bottle completely and cap it tightly. Placement. Lay the bottle horizontally on a surface that is dark and absorbs heat. Black painted metal is ideal. A piece of corrugated metal roofing painted black works perfectly. The dark surface heats the bottle from below while the sun shines through from above. Position the bottle with the label facing up if there is a label. The clear bottom side should face the sun. Better yet, remove the label entirely to maximize UV exposure. Timing. In full sun with clear sky, 6 hours is sufficient. If the sky is partly cloudy, more than 50% cloud cover, extend to 2 full days. If it is raining or fully overcast, SOTUS does not work. Wait for sun. If the water reaches 50 degrees Celsius, hot to the touch but not painful, the treatment time drops to 1 hour. If you are using a reflective surface behind the bottle, a piece of aluminum foil or a mirror, the temperature rises faster and the UV dose increases due to reflection from the backside. Storage. After treatment, the water is safe to drink directly from the bottle. Keep the cap on. The treated water remains safe for at least 48 hours in the sealed bottle. After opening, consume within 24 hours. Now, here is the industry angle. In 2006, Nestlé acquired several bottled water brands and became the world's largest water company. The global bottled water market generated $350 billion in revenue by 2023. Nestlé's business model depends on a fundamental premise that consumers cannot trust their local water and need to buy purified water in plastic bottles. In developing countries, Nestlé sells purified water for $1 to $3 per liter, a massive premium over tap water in regions where the average daily income is under $5. SOTUS directly threatens this model. If a family can purify 6 liters of water per day using free sunlight and reused bottles, they have no reason to buy Nestlé's product. In 2008, the Swiss Federal Institute of Aquatic Science and Technology, CZEEWAG, published a comprehensive guide promoting SOTUS in developing countries. Nestlé, headquartered in Switzerland, funded a counter-study the following year suggesting that SOTUS was unreliable due to weather variability. What Nestlé's study conveniently omitted, EOWAG's data showed that SOTUS users in Kenya, Bolivia, and Cambodia had 30% to 60% lower rates of diarrheal disease compared to communities without SOTUS. The health outcomes were comparable to communities with piped chlorinated water. The WHO has endorsed SOTUS. UNICEF distributes SOTUS guides in 33 countries. The Red Cross includes SOTUS training in its disaster response protocols. The science is settled. The method works. The cost is zero. 1 bottle, 6 hours of sunlight. Safe water for a family of 4. The technology has been validated by the World Health Organization, deployed by the Red Cross, and confirmed by decades of peer-reviewed research. The question is not whether it works. The question is why the $350 billion bottled water industry would prefer you never hear about it.